Section 1.5, Solving Quadratic Equations by Completing the Square and the Quadratic Formula. So we already looked at quadratic equations in 1.4, and we saw this same slide, but I wanted us to review before we learn more methods. The general form of a quadratic equation looks like this. It has 0 on one side. The degree is 2, meaning the highest exponent on the variable is 2. When we solve, we will get two solutions. Sometimes, as we saw in 1.4, it's the same solution twice. If we were to graph a quadratic equation, the shape would be a parabola. And when we solve, we are actually finding the x-intercepts of the graph. So we have already learned the factoring method and the square root property. The next method we will look at is completing the square. This method will work for any quadratic equation. So here on this slide, we see the steps for completing the square. I'm not going to read those to you. We will talk about each step as we work through the examples. But I do want to point out here on step 3, it says add 1/2 b squared to both sides. And that is actually the process for completing the square. That's like a formula that you'll need to know. But if you prefer, instead of 1/2 times b, that is the same thing as b divided by 2. So you could write it either way. It might be easier for you to think of it as b divided by 2, and of course then we will square it. And I'll show you that also in our examples. So let's go ahead and try one. Here we have a quadratic equation because it's x squared, 2 is the degree. It's in general form because it has the 0 on one side. For completing the square, step 1 is to move the constant to the other side. So when we were factoring, we did want it to have the 0, but for completing the square, we actually want the constant to be on the right side. So here we're going to add 2 to both sides. And notice that we're going to leave a space where the constant was. And remember, the word constant is just a number that doesn't have a variable that's visible. Okay, so step 1, move the constant to the right side, or the other side. It may not always be the right side. Step 2 says divide by the coefficient of x squared if it is not 1. So you look at your x squared term. If you do not see a number in front of it, it is a 1. Therefore, you can skip step 2. Step 3, that's where the formula comes in. 1/2 b squared. So I'm actually going to go ahead and write that instead of 1/2 b as b divided by 2 squared. So we're going to do that out to the side. Now, this equation is in the form ax squared plus bx plus c. b is the coefficient of the x. So for this equation, b is -6. We're going to plug that in over here for b. So -6 divided by 2, go ahead and do that first, would be -3. And then when you square, it'll be a +9. That number is going to add to both sides of the equation. We're going to add it in this space, which is why we left the space there. And don't forget to also add it on the right side. The purpose of that is to make the left side a perfect square trinomial. We talked about those a little bit back when we did the factoring review. It's when the first term's a perfect square and the last term's a perfect square and the middle sign is, or not the middle, the last sign is plus. And it will factor into the same binomial twice. So rather than writing it out twice, we're going to go straight to writing it as a binomial squared. Now, there's a couple of ways you could determine what goes inside those parentheses. You could square root the x squared, which is x, and square root the 9, which is 3. And always take the sign that is on b. So it'll be a negative sign. Now, if you're thinking, okay, I'm not sure that that works, well, you could always write it out, x minus 3, multiply those together, and make sure it equals this perfect square trinomial. Another way that you could determine this negative 3 is it is always half of b. So b was negative 6, half of that is negative 3, which is the number you'll see over here before you square. And you might use that as a check. Okay, then on the right side, we just add the numbers together. Now the equation is in the form where we can solve it by the square root property. So the squared expression is already isolated. Therefore, we would go ahead and square root both sides. So when we square root the left side, the square comes off. When we square root the right side, remember we put plus or minus square root of that number. Check to see if you could simplify the radical. Here we cannot simplify square root of 11, so the next step would be to isolate the x by adding the 3. We put the 3 in front, the plus minus in the middle, and then the radical term. And because you cannot combine the 3 with the radical, you're going to just leave it in that form. So that's a pretty basic example of completing the square, but it shows you how all of the steps work. If you need to make yourself another note here about this sign, because it's important you get this sign right, is the sign that goes in the parentheses is the sign of B. Okay, so maybe I'll note that out here. This sign is the sign of B. Okay, let's go ahead and practice another one. Number 2, the constant is already on the right side, although a space was not left, so I'm going to go ahead and rewrite that, leave a space, and then leave my negative 41 over here on the right. So look in front of your x squared. Your coefficient is a 1, therefore you do not need to do step 2. So we are ready for step 3. We're going to come out to the side and do b divided by 2 squared. Look at x. Your coefficient of x is 10, positive 10, so that's b. 10 divided by 2. 10 divided by 2 is 5. And then we square and get 25. So we're going to add 25 to both sides, add it in the space, and add it on the right side. Now we're ready to factor the left side, this perfect square trinomial. We're going to go ahead and put it in the form of a binomial squared. And to fill in the parentheses, we're going to square root the x squared, square root the 25, and take the sign of b. And again, you could check this number here should be half of b. 5 is half of 10. Same number that we have over here. On the right side, we add those together. The signs are different, so we're going to subtract and take the sign of the larger. So we get negative 16. Next step, square root both sides. So when we square root the left side, the square comes off. And don't forget to put plus or minus square root, and that whole number, negative 16, is going to go under. check to see if you can simplify your radical. And here we can, so let's do that on the next step. So it's plus or minus. 16 is a perfect square. Negative under tells us to put an I. So this becomes 4I. The radical comes off because we had a perfect square. Next step, isolate x by subtracting the 5. And then that's it, because we cannot combine an I term with a constant. We will just leave it in that form. Now just to go back to think about, we are finding the x-intercepts of the graph when we solve these. Remember we learned in 1.4, if there's an I in the answer, it means that the parabola does not touch the x-axis. There are no x-intercepts. Okay, let's try another one. In the first two examples, b was an even number. Here, b is an odd number. That makes it a little more challenging because you have to deal with some fractions, but it's still the same steps. So step 1, we're going to move the constant to the right side. Step 2, we're going to look at our coefficient of x squared, and it is a 1, so we can skip that step. Step 3, we're going to come out to the side and find b divided by 2 squared. In this equation, b is 3. So, when b is odd, it's not divisible by 2. So you're going to leave that as a fraction and then go ahead and square the top and square the bottom. So 3 squared will be 9 and 2 squared will be 4. So we will add 9/4 to both sides. Okay, now we have a perfect square trinomial on the left side. It's okay that there's a fraction in there. When we fill in the parentheses, we're still going to square root the x squared. Square root 9/4 is going to be what you had before you squared, right? So you square root 9, you get 3, and you square root 4, you get 2. Take the sign of b. Or again, you can just look here, it is half of b. Now on the right side, to add those numbers together, we need a common denominator. So let's make this 7/1 plus 9/4. And our LCD would be 4, so I'm going to multiply the top and bottom by 4. Which is going to make that 28/4 plus 9/4. So then when we add those together, we add the numerators, would be 37, and we keep our denominator. Now we are ready to square root both sides. 37/4 does not simplify, by the way. 37 is a prime number. So we square root the left side, and we put plus or minus square root of the right side. Now, for simplifying the radical, 37 has no perfect square factors, so it's going to have to stay under, but 4 is a perfect square. So I'm going to do two things in the same step here. I'm going to go ahead and subtract the 3/2 to move it over, get the x by itself. Then we'll have our plus minus. And for the radical, it's going to stay on the top. But when we square root the 4, that becomes a 2, and it is not under the radical. And we will leave our answer in that form. Okay, so it's a little bit maybe more work when b is odd, but as long as you can do the fraction work, it has the same steps and should work out fine. Now, here in a little bit, we will talk about sometimes you'll be able to choose your method, and maybe when b is odd, you might not choose completing the square as the method you want to use. But for now, we're just concentrating on this method. On the test, there will be several problems where it tells you specifically which method to use, and you will have to use that method to get credit for the problem. Okay, let's do one more example of completing the square. First step, move the 3 to the right side. So we're subtracting 3. Now, second step, we haven't done so far, but here we look at our coefficient of x squared and it's a 4. Whenever it's not a 1, we have to divide every term by that coefficient of the x squared. So that now it does become a 1 in front of the x squared minus 2x. We still need our space. And here it's going to be a fraction, negative 3/4. Now that you have your 1 in front of your x squared, you work from here and use negative 2 as b. Do not go back to your original to get b. So when we come out to this side and we do b divided by 2 squared, b is this negative 2 here. So it's negative 2 divided by 2 is negative 1 squared would equal positive 1. So we're going to add 1 to both sides. So we can get rid of that line there, okay. So we have then a perfect square trinomial on the left. Square root of x squared is x, square root of 1 is 1. The sign of b is negative. And on the right side, you may know what negative 3/4 plus 1 is right off the top of your head. If so, go ahead and write it. If you need to go through the steps of getting a common denominator, that 1 would become 4/4 because we want it to have a 4 on bottom. So then when we combine the numerators, negative 3 plus 4 is a positive 1. So 1/4 on the right side. Now we will square root both sides. Plus or minus square root of 1/4. And on the next step, I'm going to go ahead and add the 1. 1/4 is a perfect square. When we square root the 1 on top, we get 1. And we square root the 4 on bottom, we get 2. And the radical comes off. The radical comes off because both the top and the bottom were perfect squares. So now let's look at what we have here. On each side of the plus minus, we have just a number. We do not have an I, we do not have a radical. When that happens, you need to separate the plus and the minus. I think we saw that also on an example in section 1.4. So let's come over here and we need to calculate 1 plus 1/2 and 1 minus 1/2. And maybe you know the answers to those again right away. Go ahead and write them. If you need to get a common denominator, turn that 1 into 2/2. So this one gives us the answer 3/2. And over here, you probably know the answer to 1 minus 1/2, but I'm going to go ahead and show if we get a common denominator, it'll be 2/2 for our 1. And 2 minus 1 is 1, so this is going to be 1/2. And so we see the answers separate in this example as opposed to the first 3 examples. But again, the reason we did that was because This was a nice perfect square, which made us be able to combine since we did not have a radical and we did not have an I. Okay, so that is completing the square. I'm going to go ahead and stop here, and we will look at quadratic formula in the next video.